Okay, number 13, it does help if you can draw a good picture. So if I had a pyramid like that, and even if I had a pole right to the middle, so it's like a pole holding it up perpendicular to the ground, if you cross-section this thing using the altitude of the pyramid, you would have a triangle inside of it. It's like you're slicing down the middle, and that makes a triangle. Number 14. Had this up on the board today. It is a rhombus, and it says that TA is a diagonal and EM is a diagonal, but it gives it an equation too. It gives it the equation y equals negative x plus 3, negative 1x plus 3. So if that is TA, then the equation of EM has to be the negative reciprocal slope to that, because rhombuses always have 90 degrees intersection in the middle with diagonals. So we know that the slope used to be negative 1. If you flip negative 1 over 1, it becomes positive 1 over 1. So the slope has to be one of these two, because these still have negatives. Now we also know that the slope has to be, stick it in here, ready? The slope has to be positive 1, and it has to go through the point, if you look up here, 2, 1. 2, 1. So if I subtract 2 from both sides, B is negative 1. There you go. Number 15. Again, you can always have graph paper available to you. You have it available somewhere in your packet. It'll always be available on the Regents exam. So whenever you have a coordinate problem with points, graph the shape, graph whatever they're talking about. It'll make it a lot easier. So that's the point 3, 4 and 3, 12. And that is a span of 8. Between 3, 4 and 3, 12 is a vertical line of a vertical segment of 8. If the area of the triangle is 24 square units, and we know that one side of the triangle is 8, it's basically 8 times what divided by 2 equals 24. Because that's the formula for area of a triangle. Base times height divided by 2. So this number has to be 6, because 48 divided by 2 is 24. So the other side of the triangle has to be 6. So it's either going to be 6 this way, like that, or 6 like that, or 6 like that, or 6 like that. So which one of these points is one of those triangles? Let's check them all. 3, 6. If I went over 3 and up 6, I'd be right there. That's not it. Over 8, down 3. That doesn't make a triangle with a distance of 6. So let's try negative 3, 8. Negative 3, 8 would be right here. And if we're negative 3 here and 3 here, then that distance is 6. So now I have a triangle that has one side of 8 and one side of 6. Not a side, but a height of 6. So 8 times 6, base times height, is 48, divided by 2 is 24. There it is. Not very straightforward, but hopefully it makes sense. Okay, completing the square. Something we definitely have to expect on the Regents one way or another. I color-coded everything, hoping that would spark something. Remember, we have to get the x's together. So x squared minus 4x. I'm going to leave some space after that. Then I have y squared plus 8y. I'm going to leave some space there. And notice I moved the 11 to the other side, so now it's negative 11 on the right side. All constants go alone on the right. Now I take half of 4, which is 2, and square that. 4. But whatever I do to one side of the equation, I have to do to the other. I'm going to take half of 8. that's 4. Now I have to square it. 16. Whatever you do to one side, you have to do to the other. So now, I taught it this way to remind you where things come from. The square root of x squared is x. You use this sign. The square root of 4 is 2. The square root of y squared is y. You use that sign. The square root of 16 is 4. We have 20 minus 11 over here, so we have 9 on the right. I'm just going to clean it up again, make it a little bit neater. That's the equation of the circle. Remember, the center is the opposite of what you see here and here, so it's positive 2, negative 4, and the radius is the square root of that, which is 3. So center is 2, negative 4, radius of 3. Definitely one of the longest multiple choice problems that I've ever seen. But you have to remember from 8th grade science, from what I'm told, that density equals mass over volume. That's a formula that might pop up, and it's not given. So we have really 3 steps here. First, you have to solve for the diameter because they gave you the circumference. The reason you need diameter is so you can figure out radius and plug it into volume of a cylinder. Once you have volume of a cylinder, then you plug it in because you already know the density, they gave that to you. Then you'll have the volume and you're going to solve for mass. So the first step is find the diameter. It tells us that the circumference is 4.5 meters. So 4.5 equals pi d. How do you solve for diameter? Divide both sides by pi. So 4.5 divided by pi is about 1.43 for a diameter. But we really want the radius. So I'm dividing that by 2, and I get for a radius about 0.715. Try not to round off until you're done with the whole problem. Leave a bunch of decimal points until you're done and you're rounding for your final answer. If you round too early in the problem, you'll be off by a lot. So the radius is 0.715. So now I have pi r squared, and I think they gave you the height, which was 8 meters. So the volume, after calculating that, pi r squared h, comes out to about 12.84. Now we're going to take the 12.84 for volume down here. They told us the density was 752. We're looking for the mass, but we know the volume we just found was 12.84. Put a 1 underneath that, cross multiply, and you end up with, now using my math, I got about 9310, and there's a reason for that. Because number 1, we rounded here, we rounded here, and just using, I think I used 3.14 when I typed in pi, but if you use a graphing calculator, you will get a more accurate number. So I have 3 rounding places here, which every time you do that, you compound a little bit. But notice it says approximate number. The closest one is 9694. If you never rounded, that's what you get. But that'll tell you that there's no other answer close to that. Okay, I want you to use graph paper for this one. Don't draw it like I did. Use real graph paper. This is partitioning a directed line segment. 1:5 ratio is 1/6. So I'm going to take 1/6 of this distance and 1/6 of this distance. So 1/6 of the x distance is 12 that way, right? Or it's 12 that way. Then we'll take 1/6. The vertical distance is from 7 to -2, which is 9. So now we have to figure out what 1/6 of 12 is and 1/6 of 9. 1/6 of 12 is 2. 1/6 of 9 is 1.5. So right now I have 2, 1.5. But don't forget, you have to add back your first point, which was -6, -2. So it's -4 -1/2, because 1.5 minus 2. Choice 4. This problem here tells you that a rotation happened. So rotation is a rigid motion, and it'll preserve angle measure and distance and all that. It says angle L is 47 degrees. So if angle L is 47, L is right here, then so is P, because it preserves angles. You're rotating. It's the same triangle. And then it says angle N is 57. Well, N is the middle one, so K is 57. If you subtract 47 and 57 from 180, you get 76 for the remaining angle. So determine the measure of angle M. The answer is 76 degrees. That's determine the measure. But then it says explain words how you arrived at your answer. So something like, since a rotation is a rigid motion, the triangles are congruent. Since the triangles are congruent, angles are going to be the same, and they all add up to 180. Or you could say, since one maps onto the other, M maps onto J, so they're both 76. As long as you have rigid motion mapping onto M onto J, and make that into a sentence and explain why you think it's 76, you'll get the other half of the credit. Just 76 will get you 1 point. Words that make sense why that's 76 will get you the other half. This one is asking us, is the point 3.4, 1.2 on the circle? I drew it as if it was on the circle, but I'm not really sure that it is yet. If it works in the circle equation, then it is on the circle. So, does the point work? Let's see. X is 3.4 minus 1. That's H. Y is 1.2 minus a -2 squared equals 4 squared. That's the radius. So 3.4 minus 1 is 2.4 squared. 1.2, leave at opposite, is 3.2 squared. So does this equal 16? Type this into your calculator. It is 16. So since 16 does equal 16, yes, it is on the that point is on the circle, because when you plug it in to the circle equation, both sides are equal. Now justify means show your work. So as long as you have the word yes and all that work, you're fine. You don't have to explain it with words if it says justify. Okay, we have a kind of a, not a crazy proof. It's not the craziest one I've ever seen. But you'd have to, it's where you get started. Once you get started on this one, it's okay. And that's why I gave you this hint in class today. You did not, that's all it had, was 2 chords. So I added in these 2 chords. You're allowed to connect dots anywhere you want. So what that does is, it makes this triangle here, and this triangle here. If I can prove that those 2 triangles are similar, then the cross products will be equal. So let's get the given down first. So we have circle O, and we have chords AB and CD intersecting at E. That's all that was exactly what it said up here. So okay, so then we have angle 1 is congruent to angle 2, because those are vertical angles. Now watch this. See this arc up here? This angle comes from it, but so does this angle. So you could now say angles 3 and 4 are congruent because they are inscribed angles from the same arc. So you can see I have that there. And then I'm going to go ahead and say triangle CBE is similar to triangle ADE because of the angle-angle theorem. And once you have similar triangles, then you can set up the proportion AE over CE, ED over EB, corresponding sides are in proportion, cross multiply is what they wanted, and you're done.